Next topic, we are going to discuss about the effect of bandwidth on feedback. When we give the feedback, what is the effect on bandwidth? So actually we have applied the negative feedback in non-inverting amplifier. Then what will be the effect on the bandwidth we are going to see. So before going into the topic, so we have to know about some definitions. Bandwidth. So what is bandwidth? Bandwidth is the range of frequencies for which the gain remains constant. Okay, the range of frequencies for which the gain remains constant, or else the range of frequencies allowed by the operational amplifier is called as the bandwidth of operational amplifier. Next thing is the break frequency. Frequency at which the gain A is minus 3 dB down from its value at 0 Hz is called as break frequency. Okay, the break frequency is nothing but the frequency at which the gain A is 3 dB down from its value at 0 Hz. At 0 Hz, suppose if you say it is in maximum level and minus 3 dB level, at where we achieve the minus 3 dB level, that frequency is called as the break frequency, and it is also called as the bandwidth of our operational amplifier. The notation for the break frequency is F0. Okay, F suffix 0 is nothing but the break frequency. The last definition, unity gain bandwidth. Unity gain bandwidth. So here the unity gain, in the sense the gain is equal to 1, and it is the product of unity gain and bandwidth. It is a multiplication of a gain when it is unity and its bandwidth when the gain is unity. The frequency at which the gain equals to the 1. Okay, so it is the frequency or it is the bandwidth when the gain is equal to 1. That is called as unity gain bandwidth. Unity gain bandwidth is also called as a figure of merit of our operational amplifier that will be useful while comparing the amplifiers, or while selecting the amplifier, which amplifier is best. Like that, if you want to select, at that time we will take the unity gain bandwidth. So which amplifier is having more bandwidth when the gain is unity, then that amplifier is the best amplifier. Like that we will select. Okay, let us see the bandwidth, effect of bandwidth when we apply the feedback. For an op-amp with a single break frequency F0, the gain bandwidth is constant. Okay, for an operational amplifier with a single break frequency F0, the bandwidth is constant and it is equal to the unity gain bandwidth. Okay, the bandwidth is equal to the unity gain bandwidth. Therefore, unity gain bandwidth UGB is equal to A into F0, where F0 is the break frequency of our op-amp, or else it is the bandwidth of our op-amp, and A is open loop voltage gain of our operational amplifier, and F0 is the bandwidth of op-amp without feedback. And if you see the unity gain bandwidth for feedback amplifier, which is equal to AF into FF, where AF is the closed loop voltage gain and FF is the bandwidth of an op-amp with feedback. Okay, so here unity gain bandwidth is derived for without feedback and with feedback. So without feedback means without feedback gain into without feedback bandwidth, and with feedback unity gain bandwidth is equal to the with feedback gain or closed loop gain into the bandwidth with feedback F suffix F. So for a amplifier, operational amplifier with a single break frequency, these two, the unity gain bandwidth for without feedback and the unity gain bandwidth with feedback, both are same. Okay, therefore we can equate the right hand side equations. AF naught is equal to AF into FF. Okay, where AF naught is equal to AF into FF. Therefore FF, the bandwidth with feedback, can be written as AF naught by AF. So where A is the open loop gain, and F0 is the bandwidth without feedback divided by the gain with feedback. For non-inverting amplifier with feedback, so the AF can be written as, we already derived this equation from the relationship between AF and beta. So AF is equal to A by 1 plus A beta. So if you substitute AF is equal to A by 1 plus A beta, then this A will get cancelled with the A which is present in the closed loop gain. So that's why FF is equal to F0. Okay, FF is equal to F0. So A got cancelled, right? So F0 into 1 plus A beta. Actually this is in 1 by 1 by A by 1 plus A beta, which will becomes 1 plus A beta, which will go to the numerator section. That's why FF is equal to F0 into 1 plus A beta. Okay, so in this equation you can observe FF, the bandwidth with feedback, is equal to F0 bandwidth without feedback into 1 plus A beta. So here the bandwidth without feedback is getting multiplied with 1 plus A beta times. So that's why the bandwidth is getting increased when we use the negative feedback for our non-inverting amplifier. Therefore, we can say the bandwidth increases with the feedback. So it was increased by a factor of 1 plus A beta times FF is equal to F0 into 1 plus A beta. Next topic is the total output offset voltage with feedback. So first of all, what is output offset voltage? So what is output offset voltage? So actually, if we are not applying any input voltage to our operational amplifier, then output voltage must be equal to 0. Okay, if Vin is equal to 0, then V0 also must be equal to 0. But because of some reasons, or biasing voltage differences or transistors problems like that, we are getting some output voltage, okay, that is called as error output voltage. That error output voltage is called as output offset voltage. Okay, so why this output offset voltage is coming? Because of some input offset voltage that is present at the input side of our op-amp. Okay, so this input offset voltage is the voltage applied to the input of our operational amplifier in order to make the output as 0. Okay, in order to remove the error, we have to apply some input voltage to our operational amplifier. That input voltage is called as input offset voltage, VIOS. We already discussed this in the unit number 1. Okay, so because of that input offset voltage, we may get some output voltage or error output voltage. That output voltage is called as total output offset voltage. So when we apply the feedback, then what is the output voltage with output offset voltage with feedback? Okay, the total output offset voltage is given as VOOSF. So VOOS is the output offset voltage without feedback. Here F indicates that feedback. So VOOSF is equal to the total output offset voltage without feedback divided by 1 plus A beta. Okay, the total output offset voltage is getting divided by a factor of 1 plus A beta times when we use the feedback. Therefore, we can say the error output voltage is getting decreased by 1 plus A beta times. So VOOSF, output offset voltage with feedback, is equal to the plus or minus V saturation divided by 1 plus A beta times, because the total output offset voltage without feedback is the output voltage can be given as the plus or minus V saturation. The maximum is plus or minus V saturation, which was divided by a factor of 1 plus A beta. So the negative feedback reduces the effect of noise and variation in supply voltage and changes on offset voltage with temperature. The negative feedback reduces the effect of noise. So if we use the negative feedback, therefore we can get the we will have less noise also, and the variations in the supply voltage and the changes in the offset voltages with the temperature also get minimized when we use the feedback network. The features of non-inverting amplifier. So what are all the features when we use the non-inverting amplifier, so which is the feedback amplifier? So it is a best voltage amplifier. The non-inverting amplifier is the best voltage amplifier and it has a very high input impedance. The non-inverting amplifier has very high input impedance. By using the feedback, the input impedance is getting increased. So when we have more input impedance, then our network will not be the will not give loading effect to the sources. Okay, so any amplifier must have high input impedance and low output impedance. So as we are applying the feedback to our non-inverting amplifier, the input impedance is getting increased. That's why this is one of the useful thing when we use the feedback, and very low output impedance. So by using the feedback, the output voltage is getting minimized. So here the input impedance is getting increased by a factor of 1 plus a beta time. Input resistance with feedback is RIF is equal to RI into 1 plus a beta times. Input resistance is increasing like that. And very low output impedance, because the output resistance was decreasing by a factor of 1 plus a beta times. We already derived ROF, output resistance with the feedback, is equal to RO divided by 1 plus a beta. Therefore output resistance is also getting minimized. Therefore we can write n number of devices at the output side. Okay, so any amplifier must have low output impedance in order to drive more loads. And stable voltage gain. When we use the negative feedback, it provides a very stable voltage gain. The gain will automatically controlled by the feedback network. That's why the voltage gain is stable. And next one is a large bandwidth. When we use the negative feedback, the bandwidth will increases. Okay, the bandwidth increases by a factor of 1 plus a beta. Bandwidth without feedback, bandwidth with feedback is equal to bandwidth without feedback into 1 plus a beta times. So next thing is a very little output offset voltage. This output offset voltage also getting minimized by a factor of 1 plus a beta times. So which is output offset voltage divided by 1 plus a beta times for the feedback network. That's why output offset voltage, even errors are also getting minimized when we use the negative feedback. So these are all the features of the non-inverting amplifier using the feedback section. Okay, this is the one of the most important topic. And so one of the example for the non-inverting amplifier using the feedback is voltage follower. Voltage follower. This is a circuit for voltage follower. So here you can see there is a feedback from the output to the input via one wire without using any components like resistors, capacitors and inductors. Okay, so the non-inverting amplifier with unity gain can be called as a voltage follower. So why it is called as a voltage follower? It is following the input voltage. The output voltage is following the input voltage. That's why it is called as voltage follower. Okay, the output voltage follows the input voltage. That's why it is called as a voltage follower. So how to make the voltage follower circuit using operational amplifier? Just we have to connect one wire from the output side to the inverting input of our operational amplifier. Okay, only one wire is needed to give here, and we are saying it is a non-inverting amplifier, which means that the input voltage VIN has been given to the non-inverting terminal of our operational amplifier. Okay, only the non-inverting terminal we are using, and inverting terminal has been given to the feedback section, and V0 is the output voltage, VIN is the input voltage. So these voltage followers are also called as, there are many names for this voltage follower circuit, which is non-inverting buffer. Actually it is also called as a buffer, and in this case it is called as non-inverting buffer. Non-inverting buffer in the sense, so just it is propagating the signal from one stage to another stage. So when we give the Vi in, and V0 is also equal to 1, because the voltage follower has the gain of unity, only 1 is the gain of our voltage follower. Therefore V0 is equal to Vi in, input is equal to output, that is called as a buffer, and it is not giving any of the phase shift between input and output. That's why it is called as non-inverting buffer. The phase shift between input and output is equal to 0 degrees or 360 degrees. That's why it is called as a non-inverting buffer, and it is also called as source follower. So source follower in the sense, whatever is the source, that will be the output voltage. Here the source is nothing but Vi in, and output voltage V0 is equal to Vi in. That's why it is also called as source follower, and it is also called as a buffer amplifier. So buffer is nothing but just for is transferring, right? So buffer amplifier, it is also called as buffer amplifier, or it is also called as isolation amplifier. Isolation amplifier in the sense just separating the two sections. So it can be used to isolate the two circuits. So if we want to attach the two amplifier section, so which are having the mismatch in the input impedance and output impedances, then we have to use this buffer or voltage follower in order to match the input impedances. Okay, so if the input impedance of the second stage is not equal to the output impedance of the stage 1, then impedance mismatching will occur. So in order to avoid that, we are going to use the voltage follower circuit which is having high input impedance and low output impedance, which will useful to isolate the two circuits. Okay, so here how we got the unity gain. So we already know for the non-inverting amplifier, so the gain of the non-inverting amplifier is A is equal to 1 plus RF by R1. Here we does not have any RF resistor and R1 resistor here, therefore we can replace RF and R1 as zeros. Okay, so A is equal to 1 plus RF by R1, 0 by 0 will become 0. Therefore, the gain A is equal to 1 only. So that's why it is called as unity gain amplifier or buffer. This is very useful for isolating the circuit from one circuit to another circuit, and to transfer the signal from one stage to another stage without any impedance mismatching. Okay, so according to the virtual ground, we can say VA is equal to VB is equal to VI. The input voltage is equal to VA is equal to VB. Node A is directly connected to the output here. Here we can say output voltage is directly given to the A node A. Therefore, V0 is nothing but VA. So and V0 is equal to Vi in according to the virtual ground concept. So V0 VA is equal to V0, and VA is nothing but VB, which is equal to Vi in. Okay, so VA is equal to VB, which is equal to Vi or Vi in. Okay, therefore the VA node is equal to the output voltage V0. So that's why we can write V0 is equal to Vi in. So the gain of the voltage follower AF is equal to output voltage divided by the input voltage. Output voltage V0 divided by the input voltage Vi in. So V0 divided by Vi in is equal to AF, which is equal to 1. That is the gain of our voltage follower, and the input resistance with the feedback. So as we are using the feedback here, the input resistance with the feedback is equal to Ri into 1 plus A beta times. Because it is a non-inverting amplifier, the RIF is equal to input resistance with feedback is equal to input resistance without feedback into 1 plus A beta times. So here the beta network is completely absent here. So beta is nothing but 1 here. Therefore, which will becomes A into Ri, the gain into Ri. Actually, we got 1 plus A. So 1 is very much less than A. That's why we are neglecting the A here. RIF is equal to A into Ri. gain into the input resistance. Therefore, we can say if we use the voltage follower, the input resistance of our op-amp has been increased by a factor of A gain. Okay, so this is about the voltage follower and non-inverting amplifier using the feedback.